Ostatnio, ale mają właśnie długi dowód. Mike. Wait.
For example, the genitive case is here. To są buty mamy. To są buty mamy. So mamy is a word in the genitive case. It means moms. These are mom's shoes. So genitive case is used among others to show who's the owner of something. So the possession, the function of possessiveness. But genitive is also used sometimes to show the object of the sentence. For example, here, szukam mamy. I'm looking for my mom. So again, we have mamy looking exactly the same way, because this is the same case, but it's a different function. Here, we don't have anything to do with possession, it's simply I'm looking for my mom, and that's it. Or to dla mamy. To dla mamy. This is for mom. So mamy is here again in the genitive case, and we use this because of the preposition dla. Dla required this genitive case. So to summarize, one case can serve different functions. In Polish, we have 7 grammatical cases. And now let's have a quick glance at them. Let's see the names and some example. So the first basic case is
I'm
the
just
nominative
focusing
case.
on the
Nominative
first
case,
two
or in
ones.
Polish, mianownik. Mianownik. And here is an example. Dobry kot. Dobry kot. It means a good cat. So this is the basic form. And then we have the genitive case, or in Polish, dopełniacz.
Dopełniacz. Dobrego kota. Dobrego kota.
Pełniacz. And here is how the good cat would look like in this case. Dobrego kota. Dobrego kota. And then we have the dative case.
Okay. It's the same word. A good
celownik.
cat.
Celownik. And the good cat in this case would look as dobremu kotu. Dobremu kotu. Accusative case would be the next case, or in Polish, biernik. Biernik. And the good cat in the accusative case, dobrego kota. Dobrego kota. Another case is the instrumental case. And then
all of it.
The cat. Then we have also repetitions. Kota is in the genitive. Dobrym, dobrego is in the nominative. So let's say dobry is twice in the nominative and vocative case, or dobrego is in the genitive and accusative case, and dobrym is in the instrumental and locative. And then we're looking at the
But all of it
then we
means
have
the
also
same.
repetitions. Kota
No.
is in the genitive and accusative, and kocie is in the
Dobrego
locative.
kota. It's not the same exactly, obviously. Dobrego kota. Buen gatto. Okay. Buen gatto. Dobry kot. Good cat means exactly the same, but in Spanish it doesn't. No? Dobrego kota. Oh yeah, means exactly the same.
Vocative. So there are sometimes repetitions of the endings of the word. So very often we just need to read the whole sentence and from the context understand what is the case. And you could see that sometimes the cat had the same form, although the case was different, and it often happens. It often happens that the word looks exactly the same in different cases. So for example, to jest stół, to jest stół. So stół here is in the nominative case, but in the other example, kupiłam stół. So here stół looks exactly the same, but it's the accusative case. And here it has a different function. So yeah, it's not enough to see a word. You need to see the whole sentence, and from the context, then you know what is the case. Okay, we had a look at the good cat. We noticed that the endings change, and this is what happens usually. We create a different form of the word in a different case. So here's another example. Stół will be in the nominative case, and stole would be the same word in the locative case. So what we can see, first of all, there is this ending that jumped in the locative case, a, stol, stole, but also there are some alternations in the word. U became o, w became l. And then how would you know what kind of ending to put and what kind of alternation will happen? Well, it depends on many factors. It depends what kind of case is it, obviously. So a certain case has certain endings that can be attached. But also it depends on the part of speech. So if it's a noun or an adjective, there are different endings for that. It depends what kind of gender the word is. So masculine can have different endings than feminine and neuter. It also depends on the number. So if it's singular and plural, we have different endings for them. And also, for example, in singular there might be no alternations, but in plural there are sound alternations. And it also depends on the word stem. Basically, what is the ending of the basic form of the word? Then it might depend what kind of ending in the
I
case
think
you will put.
this is a little
And sometimes
advanced.
also the
I mean,
meaning is
usually
important.
I did learn
For example,
English,
if this is
and
a
I did learn
person,
just using it, not
there is a different ending.
understanding
And if
the
this is
grammatic.
an object,
I mean, it's not
then there
perfect
is
my
a
English.
different
I make
ending.
mistakes,
All
but
those
I'm
things
able to
often
speak.
need to be taken
So,
into consideration when
but
selecting the
I would
correct
like
ending or
know
making some sound
why the words
alternations.
change.
So the thing is to
For
understand
that, I'm doing
what kind of
this.
cases we have in Polish and what kind of functions they serve. Very often, one case serves more than one function. Then, how to create the form of the word. So what kind of ending will be there, so you can recognize this case and yourself be able to create that. So this would be the introduction to the Polish cases.
Okay, well, I speak Spanish. That's my mother language. So I will watch this episode, this video,
Poznaj
because it's in
Copilot,
Spanish.
rewolucyjne narzędzie
So
zasilane
it's
przez
easier for
AI
me
wewnątrz
to get some
Bitrix24, które robi niesamowite.
¿Cómo decir alguien en idioma polaco? Puede ser que es tan fácil que simplemente vas a decir alguien como en idioma español. Obviamente que no. En idioma polaco necesitamos complicarnos la vida y vamos a tener varias formas para decir alguien. Puedo decir alguien usando la palabra ktoś, o puedo decir alguien kogoś, o puedo decir alguien komuś, o puedo decir alguien kogoś, alguien kimś o alguien kimś. Obviamente que sí lo puedo decir. Obviamente que lo puedo decir porque obviamente todo depende de los casos. Y como ves aquí, si ya conoces los casos, gracias quizá a otro video que está en YouTube y que tiene un montón de vista sobre los casos en idioma polaco, aquí tienes mianownik, dopełniacz, entonces nominativo, genitivo, dativo, acusativo, instrumental y locativo, y correspondiente a eso la pregunta ¿quién? Y obviamente responde a eso la pregunta corresponde a la respuesta alguien, ktoś, kogoś, komuś. Entonces, bueno, yo preparé para ti algunas preguntitas, solo dos, para que entiendas qué es eso. Vos seguramente cuando entras a una habitación y escuchas un ruido o te parece que alguien está
Who is
allá,
here?
que vas a preguntar ¿Ah? ¿Kto tutaj jest? ¿Kto tutaj jest? Pero bueno, quizá es Juancito, quizá es Dianita, quizá no sé. Pero a veces también puedes responder alguien está aquí. Y bueno, en esta estructura que es simplemente kto, entonces caso nominativo, vamos a preguntar czy ktoś tutaj jest, ¿sí? La palabra kto en nominativo tiene su referente a alguien, ¿sí? Pregunta-respuesta, kto, ktoś. Entonces, bueno, aquí tengo que usar alguien porque de verdad es una frase afirmativa, ¿no es cierto? Alguien está aquí. Yo puedo borrar este che porque te acuerdas que la palabra che te sirve solo para la pregunta sí o no, ¿sí? Si no sabes todo eso, te envío a mis cursos autodidactas donde explico todo eso paso a paso. Entonces vos puedes decir alguien está aquí. Ktoś tutaj jest. Y puedes tener una pregunta también. Czy ktoś tutaj jest? ¿Alguien está aquí? Otra pregunta, puedes preguntar para el caso genitivo, es la pregunta quién se dice kogo, ¿sí? ¿Quién, kto y quién, kogo es lo mismo. También hay otro video sobre todas las preguntas para quién y qué, cómo cambia según los casos en idioma polaco. Si no, te invito a YouTube. Este video justamente está gratis. Entonces, vos preguntas, ¿quién falta aquí? Si estás en una reunión y bueno, quieren empezar y dices, bueno, pero kogo tutaj brakuje? ¿Quién falta? Kogo tutaj brakuje? Y si yo quiero decir, pero ¿a alguien falta o no falta? Dime solo sí o no. Voy a la respuesta para esto.
Ok. Ok. Ya casi se me termina el tiempo, entonces. Cursos.
Lekarzowi.
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 Dziadka. Lekarz. Dziadkowi. Deser.
¿Qué pasa, mami? ¿Ah?
Sí, bueno, yo creo que por allá buenos días. Aquí van a ser las 11 de la noche. Primero que nada, ¿cómo siguió Viecha? Ella saca un videillo y una foto a Toy. Ahorita venga, Toy.
Dime, ¿por qué tan tarde? Ahí en la calle.
Nauczyciel.
Videsha, pues ahí está bien, gracias a Dios. Eso del problemilla de la panza, y no sabemos qué es todavía, pero ahí está bien.
Nauczyciel.
Check. Just this one. Dziadka. Czytam.
Czytam.
Tu jest
Deser.
deser. Czytam. Kawa.
Książka.
Książka.
Deseru.
Deseru. Deseru.
Dziękuję.
Dziękuję.
Studentka.
Studentka.
Przepraszam.
Przepraszam.
Deseru.
Deseru. Seru.
Czytam.
Czytam.
Fotografia.
Fotografia.
11.
11.
Kompozytor.
Kompozytor.
Poniedziałek.
Poniedziałek. For me it's this one. Composi. Oh no.
Kupili.
Kupili.
Kupiliśmy. Pracowały. Pracowaliśmy. Oglądali. Oglądaliście. Słuchaliście. Słuchałyśmy. Słuchałyśmy. Spacerujecie. Spacerowaliście.
Telefonujecie.
telefonowaliście?
My to znamy. My to znamy.
My to znamy.
Znamy. Mamy. My to znamy. Znamy.
No section here. Znamy. I know that. O kurwa. No. Wiem, znam. Znam.
Czy wy znacie tamtego psa?
Czy wy znacie tego?
Czy wy znacie tamtego psa?
Czy wy znacie tego psa?
Tamto. Tamtego. Znacie tamto zwierzę?
Oni znają tego kota. Mają. Znają. Ona. Zna. Tego. Tego. Zna. Ona. Zna. Tego. Psa.
One znają i kochają tamtego mężczyznę. One znają i kochają tamtego mężczyznę. Ona zna tego.
Psa.
Czy znacie tamtą kobietę? Czy znacie tamtą kobietę? My
Znamy.
nowi mężczyźni znają tamtą kobietę.
Czy
On zna tę.
kobietę? Znasz tamtą kobietę?
Znam kobietę. Znamy tamtego mężczyznę. Tamtego. Tamtego. My
To. Znamy.
nowi mężczyźni znają tamtą kobietę.
Welcome back. Now that we know how to get an actor's location, it would be useful if we could set the actor's location to a location in space that we specify. Now, we'll first learn how to do this in Blueprints before we move to C++. So let's drag off of Begin Play, and we're going to search for Set Actor Location. Now, this is a function that requires a couple. Welcome back. Now that we have some experience creating actors, it's time to move on to the pawn class. Now, we've already mentioned that a pawn has additional functionality in addition to the functionality it inherits from the actor class. For one, it can be possessed by a controller. Now, this brings a whole new level of possibilities because if we're possessing a pawn, that means that we can control the pawn. We can add input such as keyboard presses and mouse clicks, or just moving the mouse. Use this data to move our pawn. And that's what we'll focus on in this section. So we're going to need a pawn. Now, I'd like to create a basic pawn so we can just learn how pawns work. And for this, I'd like to make a bird class. So we'll make a bird that we can possess and fly around to take a look at our level and get a sort of bird's eye view. So to make a new pawn class, we're going to go to Tools and select New C++ Class. And this time, we're going to choose the pawn class as the parent. Let's go ahead and click Next. And we can choose private or public. For this course, we're going to continue using public. So the header file is in the public folder, and the source file is in the private folder. Now, I'd like this bird class in its own folder, and I'm going to call this folder Pawns. And we're going to call this class bird. So let's create this class. We'll click Create Class, and Visual Studio is going to ask me to reload all as soon as it loads. So we're going to click Reload All. And now we're presented with two new files, bird.h and bird.cpp. And we see them here in the Pawns folder. We have one Pawns folder in the private folder and one Pawns folder in the public folder. Now, just like the actor class, when we create a new class based on pawn, we get lots of boilerplate code already included for us. There's our generated.h, we have our generated body, and we also get a public and a protected section, along with a second public section down there. And Unreal Engine does us the courtesy of creating a constructor for our new class. Since our class is called aBird, it is an actor after all, as pawns are derived from actor. So it gets that A added to its name in C++, even though in the Unreal Engine editor, Unreal Engine goes ahead and removes that A for us, such as in the Blueprint editor. Now we also get begin play, so we have that override, as well as the tick function. And in addition, we have this new function that we haven't seen yet. And this is called Setup Player Input Component. Now, an input component allows us to take input, pressing a keyboard key, moving the mouse, etc., and we can access and use that data to move our pawn. So already we're seeing that the pawn has more functionality than the actor class. Now we know what a constructor is good for, setting default values for this pawn's properties, so we don't really need that comment there. We also know what begin play does, so we're going to remove that comment, as well as the comment for tick, and we'll leave the comment on setup player input component for now, at least until we get some experience learning how to use this function. And we'll get to that soon, don't worry. Now I'd like to have my public functions all in the same section, so I'm going to highlight the line with the tick function and move it up to the first public section there. And I'm going to do the same thing for setup player input component. So I'm going to highlight both lines, including the comment, and bring it up there. Now we're not using this public section, so I'm going to...
Espera un toque. Control Alt F11.
remove that, and we just have public and protected. Now let's head over to bird.cpp. We see that it includes its own header file, as CPP files must have, and it also has some helper comments here, and we're going to remove these as well from the constructor, as well as begin play, and the tick function. And all the way down here at the bottom, here's setup player input component. Now this is an override of a parent function inherited from the pawn class, which is why we're calling super here, just like begin play and tick. Okay, so we have our basic pawn class. So what we can do is go ahead and save everything. And back in the editor, we see that live coding has started as soon as we created that class. So we can close that window. And if we look in our C++ clashes/public pawns folder, here's our bird class. And again, Unreal Engine strips away that A, but we know that this is a pawn, and anything derived from actor and below, such as pawns, has A in the name, at least in C++. So it's really an A pawn, and the class is called ABird. Now we can create a blueprint based on this class. And in our content folder, we have based in C++. So it's really an A pawn, but we know that this is a pawn, and anything derived from actor and below, such as pawns, has A in the name, at least in C++. So it's really an A pawn, and the class is called ABird. Now we can create a blueprint based on this class. And in our content folder, we have blueprints. I'm going to go ahead and right-click and make a new folder here called pawns. And we'll create a new blueprint based on the bird class. So let's go ahead and right-click, create a new blueprint class, and under all classes, we'll search for bird. And here it is. We'll select it, and now we have a new blueprint, and I'm going to call this BP_bird. So now we know that this is the blueprint class because it's prefixed with BP. And if we double-click this, we can open it, and it looks a lot like the blueprint editor when we were looking at our actor class. We have a viewport, we have a details panel, as well as a components panel, and there's our default scene root. We haven't created any components, and we haven't reassigned anything to be the root component, so we still have our default scene root component. And we have the construction script and the event graph. So far this looks basically identical to an actor, but we'll be adding more functionality to our bird class. And we'll start doing that in the next lecture, but before we wrap up this lecture, I'd like to get some assets to use for our bird. If we're going to call this bird, we should have a bird mesh, for example. So I'm going to pull up the Epic Games launcher and go to the marketplace. And here in the marketplace, we can hover over free and select permanently free collection. And if we scroll through the permanently free collection, we see that there are multiple pages. We can go to page 2, and I don't see any animal assets. Let's go to page 3. And here we have Animal Variety Pack, which is free. You can see that I already own it, as I've already checked out this pack. And it has several animals. And if we scroll down here, we see that in the technical details, these animals are rigged, which means that they can be animated. In fact, it says animated yes, which means these are animated, so we can use those animations. And there is in fact a bird, looks like a crow. So since we have a crow in this pack, we can add this to our project. So I'm going to click
Animal Variety Pack.
Add to project and search here. And there is in fact out this pack. See any animal assets? Let's go to page 3. And here we have animal variety pack, which is free. You can see that I already own it, as I've already checked out this pack. And it has several animals. And if we scroll down here, we see that in the technical details, these animals are rigged, which means that they can be animated. In fact, it says animated yes, which means these are animated, so we can use those animations. And there is in fact a bird, looks like a crow. So since we have a crow in this pack, we can add this to our project. So I'm going to click add to project and search here for slash. So here's my / project. I'm going to go ahead and click Add to Project.
No lo puedo abrir. Este. No sale. Vamos a ver, no. Open. Ci sta. Anyone? I'm gonna add it here.
And it'll take a minute. And once it's done, I can close the Epic Games launcher and come back into /. And now I have a folder in the content folder called Animal Variety Pack. Go ahead and go through and check these out. I'm interested in the Crow folder, and each of these folders has a maps folder with an overview map. We can double click that overview map. And here in this map, we see a bunch of birds. Now the cool thing about this map is this is sort of a showcase showing us all the animations. If we press play, now we see all the different animations, and they're just looping. So this is pretty awesome. We now have an animated bird. So we can use this for our pawn. And that's what we'll be doing in this section as we make our bird pawn class. Great job. I'll see you in the next video.
Capture the component.
Welcome back. Now that we have a pawn class, it's time for us to start adding some components to our pawn. So here's our pawn. It's called BP Bird. Now we just have a default scene root. Now we're definitely going to want a mesh so we can see the bird itself. But that's not the first component we're going to add. We're actually going to start with a capsule, and we're going to use this capsule for basic collisions in the world. Let's talk about why. Every mesh in a game is made up of polygons. So our simple bird here actually has quite a few polygons that make up its mesh. Now for this particular bird, this isn't a very large number of polygons as far as meshes go, but it's still a lot if we want to detect collisions. Let's say that in our world we have some object flying towards the bird, and eventually that object may collide with the bird. And we may wish for the engine to detect this collision so something can happen in response. Now, checking for collisions against the mesh itself is very expensive. This bird is made up of lots and lots of polygons, triangles to be exact. And to detect a collision with our actual mesh, this would require the engine to perform lots of calculations under the hood to see if this flying object has collided with any one of those polygons. So because this is an expensive operation, we typically have a different solution. We use a more basic shape for our collision, such as a capsule. If our bird has a capsule component, then when an object comes along and it gets close enough to the bird, as soon as it collides with that capsule, we can detect that, and the engine can perform a vastly lower number of calculations to do so. So for this reason, we often have a component that has some basic geometry designed for handling these collisions. So let's talk a little bit about a capsule component. Unreal Engine has a class called UCapsule You see the U there? That should tell you that this is derived from UObject and is not an actor. So we know about the UObject class, and derived from that, we have USceneComponent, which has a transform and the ability to support attachment. Derived from USceneComponent, we have UCapsleComponent. Now, this is an oversimplification of the inheritance hierarchy. There are other classes derived from these objects, so this chain is much longer than we see here. But what we're concerned with is the capsule component. We know that it's a USceneComponent, so it supports attachment and has a transform. And a capsule component is used for simple collision. It's really easy to detect collision with a capsule. Its geometry is very simple. And it also has the ability to be rendered as red lines in the editor, so we can visualize it and see what that collision volume looks like. So let's add one of these capsule components to our bird class. So we'll jump back into Visual Studio and go into bird.h. And I'd like to add a capsule component variable to our class. Now, this can be a private variable. It's generally a good idea to keep variables private if we don't plan on exposing them to other classes. And a capsule is sort of internal information for this pawn. So we're going to add a private section down here at the bottom. And we can make a UCapsule component pointer, and we can call this capsule. Now notice right off the bat that UCapsule component gets red squiggles. And if we hover over it, it says identifier UCapsule component is undefined. And if we tried to compile this, we'd be met with a
UCapsule component. UCapsule component capsule component include UCapsule component. Isn't working. U capsule component. Qué raro. Ok. Esse aqui. Vamos. Components. Añadir cápsula component C++. Este.
Compiler error. Capsule component pointer, and we can call this capsule. Now notice right off the bat that uCapsule component gets red squiggles, and if we hover over it, it says identifier uCapsule component is undefined. And if we tried to compile this, we'd be met with a compiler error. Let's go ahead and compile and see what happens. First, I'm going to close out of the Unreal Engine editor as we're compiling here from Visual Studio. And I'm going to go ahead and hit Control B to compile this module. Let's see what the compiler tells us. Now, we have several error messages. We see some syntax error messages talking about missing semicolons before the asterisk. That's because it doesn't really expect us to create a pointer with a type that it knows nothing about. So it's wondering if maybe we meant to say uCapsule component semicolon or something like that, which of course we didn't. Now all of these messages are referencing bird.h at line 24. That's what this 24 in parentheses means. So our simple capsule component pointer is wreaking all sorts of havoc in the error log. It says missing type specifier int assumed. So because it doesn't recognize this as a type, it's wondering if maybe we forgot to include the type. Now all of these errors can be avoided by so because it doesn't recognize this as a type, it's wondering all sorts of havoc in the error log. It says missing type specifier int assumed. So because it doesn't recognize this as a type, it's wondering if maybe we forgot to include the type. Now all of these errors can be avoided by simply making sure that we don't use undefined types. Now this type is defined in Unreal Engine, but it's defined in a specific header file. Let's figure out what that header file is. Now here's the Unreal Engine 5 documentation. This can be very useful for a number of reasons. For one, it has lots of walkthroughs that can teach you things. But perhaps the most valuable use of this is that we can look up classes here in the search bar. I can search for uCapsule component,
Wait.
and we
Fuck. Fuck. Okay. Here. Unreal Engine document. ¿Qué pasa? uCapsule component.
have uCapsule component along with the uCapsule component functions that it may think we're interested in. Now, if we click on the first link here to uCapsule component, here's the documentation for it. And it says, a capsule generally used for simple collision. Bounds are rendered as lines in the editor. And it also shows the inheritance hierarchy with uCapsule component at the bottom. Notice that it shows uObject here. And it shows that uObject is derived from uObject base utility, which is derived from uObject base. Remember, I told you the inheritance hierarchy was more complicated than what we were looking at in our slide. Now, based on uObject, we have uActor component. Based on that, uScene component. Then uPrimitive component. Then uShape component. And finally, uCapsule component. So each child class further down the hierarchy adds more and more functionality. And the uCapsule component is down here at the bottom in this chain. Now, under References, it shows us where the header file exists in the engine, where this class is defined. And it also shows us that if we want to include that header file, we only need to include this part of the path. Everything after classes doesn't need to be included. Visual Studio will know where to look for this header file as long as we provide components/capsulecomponent.h. Now, beneath this, we have variables, and the main variables that belong to this class are the capsule half height and the capsule radius. These will determine the shape of the capsule. Now, we see that it has a constructor as well as some functions, and most of the functions have a short description. So definitely use the documentation as a resource whenever you need to find out information about a particular class in the Unreal Engine hierarchy. Now, the reason I'm coming to this documentation page is because we need to include the header file where capsule component is defined. So I'm simply going to copy this include here and come back into Visual Studio. Now, if I wish to get rid of that compiler error, perhaps the easiest way would be to scroll up to the top here and include it. Now, something you should know, if you're going to include header files in an Unreal Engine header file, we need to include it before the .generated.h header file. The .generated.h must be the final include. It must be the last one, otherwise we'll have errors. And that's because when Unreal Engine includes this header file, the preprocessor will paste in tons of lines of code auto-generated for this class to work and integrate with the reflection system. So we need to make sure to include this above the .generated.h file, so we can include it here. Now that we're including capsule component.h, if we scroll down, notice the red squiggles are gone. And if we hit Control B to compile, we'll see that we've succeeded. At the bottom it says build 1 succeeded, which means no compiler errors. We've successfully compiled. Now, including the header file right here in bird.h is not the best practice in general, and we'll learn why in the next lecture, but for now, since we know that this compiles successfully, we can create our capsule component. Now, if we wish to see it in the Blueprint editor, we have to expose it to blueprints. That means we need a uProperty. So let's add the uProperty macro to this, and we can make it visible with visible anywhere. Now, we know that this variable is just a pointer. We haven't actually created a capsule object. Remember, we need to create a default sub-object for our capsule, and we do that in the constructor. So let's go into bird.cpp, and we'll do that here in the bird constructor. So what we'll do is we'll say capsule equals, and we'll use create default subobject. And we'll specify uCapsule component, and we also need to specify an internal name for this. We can call this capsule. So we're using the create default subobject factory to create the default subobject for our capsule. Now, if we want to, we can make the capsule our root component, and then that default scene root will be gone. And this is typically what we do with capsule components. We usually make them the root. You don't have to, but for this class we will. Now, root component is protected, which means we have access to it in child classes. So if we wanted, we can say root component equals capsule and overwrite the root component this way. Now, we also have the inherited setter function, set root component. And we can set the root component by passing in a scene component. And we know that capsule is a scene component, so this will satisfy this input. So we can pass capsule in here, and this would do the same thing. Now, whether we use assignment with the assignment operator or the setter function set root component, the result is the same. If we use the setter like this, then somewhere down the line, if Unreal Engine decides to make the root component a private variable, then our code would still compile because set root component is a public function. But either way, we're setting the root component to be the capsule. So we can compile this and check it out in the editor. Now, I've closed my editor, so I'm going to hit Control F5 to compile and launch the editor. And I'll go ahead and click Open down here at the bottom right, and click Open Full Blueprint Editor. And here in the Components panel, I see my capsule, and it's now the root. And if I click on the Viewport tab, I see my capsule in the viewport. Now, it's kind of scaled up for a sort of humanoid figure. We could place a human character there, for example, and the capsule would pretty much cover the volume of that character.
Aqui, Blueprints, Pawns, Testament.
But we can change the capsule half height and the capsule radius by selecting our capsule. And in the Details panel, under Shape, we have those variables here. And we can assign values directly into those boxes, or we can click and drag them to change those values in a smooth manner. Now, we can drag the capsule half height down until we have a really small capsule, something like what a bird would need. So I think a capsule half height of 20 and a capsule radius of 15 is probably good for now. Now, if we wanted to set these from C++, we could do that too. Back here in Visual Studio, after we've created the capsule, we can access those variables. So I can say capsule, and this is a pointer, so I'm using the arrow operator here, and I can type capsule half height. And if I scroll down in this pop-up, I see this function, set capsule half height. That's a public function that we can use. Now, it has an input parameter of type float called half height, so we could pass in, say, 20.f here. Now, the second input is a Boolean called update overlaps. It's set to true by default. This means that if our capsule is set to trigger events in response to overlaps, which is something we'll learn about later, then scaling the capsule like this will allow it to check to see if it's now overlapping with something after changing that half height. Since that input has a default value, we don't need to pass one in. We can leave it at its default value of true. Now we can set the radius similarly. We can take the capsule variable, and there's a function called setCapsleRadius. And it has a float for the radius. We can pass in 15.f. And it has the same Boolean, bUpdateOverlaps, set to true by default, so we don't need to pass that in. So now we've set this in C++. So now that we have a capsule, we can use the capsule for collisions, and we don't have to use our actual bird mesh, which we don't have yet. We'll add that soon. But this is our first step, adding our capsule component, and we've assigned it to be the root component for our pawn. Great job! In the next lecture, we're going to talk a little bit more. Welcome back. In the last video, we added a capsule component, and we saw that just declaring a new uCapsule component pointer in our birds header file resulted in a compilation error. And we resolved this error by including the capsule component header file right there in bird.h. And I mentioned that this is not the best practice. So in this video, we're going to talk about why that is. Now imagine we have a class called creature, and in creature, we like a capsule component pointer. Now we know what will happen. The compiler will get angry and give us red squiggles here. And we saw that to get rid of those squiggles, we included the capsule component header file, and the compiler was happy. Now what happens when we do this, however, is as soon as we compile, the preprocessor sees this include and goes and finds capsule component.h. And it literally replaces that include line with all of the contents of capsule component. Now, uCapsule component is a class defined here in capsule component.h, which means by the time the compiler reaches our variable, it sees that this type is defined. The problem with that is that capsule component.h contains all of the code in the capsule component class, as well as other includes that the capsule component header file needs, which means all of these include statements are added to creature.h, and the preprocessor goes and finds those header files and takes the code inside of those files and pastes it right here in creature.h. So creature.h has just become a great deal larger. Now the truth is that the compiler doesn't actually need to know all of those details just so we can have a capsule component pointer. The compiler really only needs to know the details about the capsule component, specifically how large it is, in certain situations. We need the size of capsule larger. Now the truth is that the compiler doesn't actually need to know all of those details just so we can have a capsule component pointer. The compiler really only needs to know the details about the capsule component, specifically how large it is, in certain situations. We need the size of capsule component when actually constructing an instance of the capsule component type. So the size of the class is important here. The size of the class is not important to simply create a pointer, as a pointer is designed to hold an address. So all pointers are the same size. Now this creature class has a constructor, and that's where we would actually construct a capsule component object using create default subobject. Now this action does require that we have the size information for the capsule component, so we can allocate that much space in memory. So if we could get away with not including the header file in creature.h and instead include it here, well then we're actually including the header where we need it. There's no getting around it here. We need capsule component to be defined in order to construct an object of this type. So what we can do instead in creature.h is as soon as we declare a new variable of type uCapsule component pointer, we can forward declare. This class keyword here means we're forward declaring the uCapsule component type. Now a forward declaration just means that we're declaring a class type without actually defining it. So we're telling the compiler that the uCapsule component type is not defined here in creature.h, but you can look for it elsewhere, wherever we use uCapsule component in a circumstance where we would need that information, such as creating a new object of this type. That's going to be in creature.cpp. So when we forward declare, uCapsule component is considered an incomplete type here in creature.h. An incomplete type being a type that describes an identifier, in our case uCapsule component is the identifier, without information needed to determine its size. The information that we would need to determine that class's size would be the class declaration itself. That would be in capsule component.h. So until the compiler can actually see where the uCapsule component class is defined, uCapsule component here is an incomplete type, and our usage of it is limited. We can only create a pointer of this type, but we can't do things like access member variables or functions, or create an actual object of this type. We don't have any of that information. All we know here is that this is a pointer. So here in creature.cpp, where we're actually creating an instance of the uCapsule component type, we'd get a compilation error as long as uCapsule component is an incomplete type. So how do we complete the type? Well, that's easy. We simply provide the definition for the class. And we do that by including the header file, as the class is defined in the header file. And once the preprocessor replaces this include line with the actual contents of that header file, this class type will be defined here in creature.cpp, and uCapsule component will no longer be an incomplete type. Now, you might be thinking, we're still including capsule component.h, so what's the difference if we're including it anyway? We can include it in the header file, and then we won't have to bother forward declaring with that class keyword, so it's really less work for us, right? Well, let's see what happens if we're in the habit of doing this all the time. Say we have a class called weapon. Now, weapon might need to include the header file for a class called mesh, which might be defined in mesh.h. It may also need a box component, so maybe it's including that as well. And perhaps weapons have a magic effect, and this class may be defined in magiceffect.h. So we're including all the header files that we need here, and now we can create variables of those types here in weapon.h. So far so good. But then let's say we create a new class called inventory kit. And in inventory kit, we might need to use the weapon class. We may have weapon variables, right? So we may include weapon.h here. But because we're including weapon.h, the preprocessor is going to paste all the code in weapon.h, and it's going to see that weapon.h includes header files of its own. So it's going to go find those header files and paste their code in here as well. Now, inventorykit.h doesn't need mesh.h, it doesn't need box component, it doesn't need magic effect. It only needs the weapon class, as it's only going to have weapon variables. Now, on top of that, let's say inventory kit uses the armor class and the potion class. So it's including those header files. So inventory kit is getting quite large at compile time. But it gets worse. Let's say we have a warrior class. Now, warrior may have an inventory of its own. So if we want a inventory variable on the warrior class, say we include inventorykit.h in the warrior class. But that means we're going to get all the contents of inventorykit.h, which means we're including armor, potion, and weapon. And not only that, inventory kit includes the weapon header, which means we're getting mesh, box component, and magic effect. That's 6 new header files that we don't even need. The warrior just needs an inventory variable. It does not need all of the code in all these other header files. When the header files get large like this upon compilation, this is known as code bloat. And this can slow down compile times a great deal. So this is one reason why we should only include those header files where we actually need them. Now instead, let's say we include our mesh, our box component, and our magic effect header files only in weapon.cpp, where we're going to use those types. Now, CPP files are not typically included anywhere. So we can use the weapon class in our inventory kit, and let's say we only include weapon.h in inventory kit. Now we're not getting mesh, box component, or magic effect included in the inventory kit header file. They're only included here in the CPP file where they're needed. Now, inventory kit can include armor and potion in its CPP file as well, so those are also not in inventorykit.h. So when we get to our warrior class, our warrior can forward declare inventory kit so that it doesn't need that header file in warrior.h. We can simply include it in warrior.cpp. And by doing so, we only get the code in inventorykit.h, which does not include mesh, box component, or magic effect. On top of that, it doesn't include armor or potion. So we're only including a single header file for inventory kit without all the other code that we didn't even need to use in Warrior. So this is a great reason for forward declaring and only including header files where we actually need to use them, in CPP files. There's another reason for forward declaring. It has to do with circular dependencies. Let's say we have a class weapon.h which needs to include warrior.h. And then we might have another class called warrior.h, which needs to include weapon.h. Now, if we did this, we'd get a compiler warning. The compiler would complain that it's detected a circular dependency. These two header files depend on each other, and this is not really possible to do. How can you include weapon.h, which includes warrior.h? The preprocessor doesn't know how to handle this. It would see warrior.h, find that file, and include it here in weapon.h, but then it would find that warrior.h requires weapon.h. So it would go back and find weapon.h, which needs warrior.h, which needs weapon.h, and we have this infinite loop that cannot be accomplished. So circular dependencies are not good. And if we're in the habit of including headers in other headers, circular dependencies can happen. So this is yet another reason to forward declare and only include the header files we need in the CPP files where we use those types. Now the solution to this is simple. All we do is include warrior.h in weapon.cpp. Weapon.cpp isn't going to be included anywhere, so we don't have the risk of circular dependencies. Likewise, we include weapon.h in warrior.cpp. This is totally fine. We can include warrior.h in weapon.cpp because warrior.h does not include weapon.h. We place that include in warrior.cpp, which is not being included anywhere. So this prevents circular dependencies, and this will compile just fine. Now, it helps to know when we need to include header files. We must include header files when inheriting from a parent class. So that's why you do sometimes see header files included in other header files. Hopping back into the editor, we see that our bird class inherits from the pawn class. Now we can't possibly inherit from pawn without having details of the pawn, such as its size and its member functions and variables. So that's why Unreal Engine provided this header file automatically when it generated the class. So inheritance does require that we include the header file here in another header file. Now you also see core minimal and the .generated.h file. These are also needed, hence why they're automatically included, as there are some types that we need in core minimal, so we're including it here. And you will notice that core minimal is included in lots of different files. You'll see it here in item.h as well, all the way up here at the top. Now, we won't get a circular dependency because core minimal contains lots of basic information that we can include in all of these header files, and we'll never include it twice because it contains its own pragma once. And if you don't know what pragma once is, it's a guard that prevents us from including the same header file twice anywhere. So if I included item.h somewhere else twice, pragma once will recognize that and only include it once. So we know that we need a header file for a class inside the header in which we're inheriting from that class. We also need the header when we need the type size, as we saw with creating instances of that class. So using a factory to construct an instance of the class requires that we have that header file included for the class. We also need the header file for a class if we plan on accessing member variables and functions from that class. So it can't be an incomplete type if we're accessing variables and functions from it, as that information is included in that class's header file. That's why we declare functions and variables in header files. So we'll be making use of these best practices throughout this course, only including header files where we need them. And we'll start with our capsule component. So we'll go back to bird.h, and instead of including capsule component here in bird.h, we're going to cut that out. So I'm going to copy it and delete it and head over to bird.cpp and include it here instead. Now that it's included here, we can construct a new capsule component using create default subobject. But remember, As soon as we remove the header file from bird.h, we had that compiler error, which means we need to forward declare the uCapsule component type here. Now, if we do that, we can go ahead and compile. Once again, I'm going to close out of the editor first, and from here in Visual Studio, I'm going to hit Control B to build this. And I have a successful compile. So we've successfully forward declared a class. Now, once you've forward declared a particular class type, you can then use it from that point on in the header file. So if I created another uCapsule component pointer called second capsule, you'll see that I don't get any compiler errors. And this does compile just fine. That's because the compiler already knows that this type has been forward declared. But if I try to, say, declare this variable up above the forward declaration, right here, I would pointer, particular class type, you can then use it from that point on in the header file. So if I created another uCapsule component pointer called second capsule, you'll see that I don't get any compiler errors. And this does compile just fine. That's because the compiler already knows that this type has been forward declared. But if I try to, say, declare this variable up above the forward declaration, right here, I would get a compiler error because it hasn't been forward declared yet. And the compiler goes through this file line by line, starting at the top. So by the time it reaches this line here, it's not going to know what this type is. If I hit Control B here, then I get compiler errors. And these look like the errors that we've already seen. So for that reason, some people like to forward declare classes they're using all the way at the top of the header file, just under all the includes. So we can do that instead. Here's how we do it. Right here above the class, it can be outside the class, that's fine. We can forward declare uCapsule component here. So we say class uCapsule component with a semicolon. Now this class has been forward declared and we can use it anywhere down here. I can remove the class keyword from our variable, and if I hit Control B to build, fine, we can forward declare uCapsule component here. So we say class uCapsule component with a semicolon. Now this class has been forward declared and we can use it anywhere down here. I can remove the class keyword from our variable, and if I hit Control B to build, I have a successful compile. So forward declaring all the way up at the top means we can use that type anywhere. So some people like to forward declare on the same line where they declare the variable like we first did. Other people like to forward declare up here at the top, and they just keep all their forward declares right here in a nice little list, and that way they can use that type freely throughout the header file. Both methods are legitimate. I'll go ahead and leave our forward declaration here at the top for our capsule component variable. And I no longer need this second capsule as I just created it for demonstration purposes. So now that we've forward declared our capsule here at the top, we're not including the header file here as we don't need it, simply to create a pointer variable. We're including the header file in the CPP file where we do need it to construct an actual capsule component. And this is better programming practice. Now, you might be wondering why we didn't have to forward declare the static mesh component type. for our pointer variable here in item.h. We didn't forward declare it, and we didn't include its type at the top, and yet we didn't get any compiler errors. Well, the uStaticMesh component type is already included by default. Our item class is based on actor, and actor does include header files in its header file, actor.h. And the actor.h header file includes some header files of its own, and some of those include header files, and somewhere up the line, the static mesh component is already included or forward declared, so we don't need to forward declare uStaticMesh components in actor classes. So if you ever get a compiler error for having an undefined type, then you probably need to forward declare. And if you're not sure, it's always safe to just forward declare anyway, and just include that header file where you need it in the CPP file. But in our case, we could compile without including static mesh component, so we're safe here. But in the capsule component case, we did have to forward declare, so we have that here. Great job! I'll see you in the next video. Shape of mesh that can animate. It's called a skeletal mesh component. Now we know about the UObject type, and we know that uScene component is derived from it. And we saw that the static mesh component is also derived from uScene component, but so is the skeletal mesh component. uSkeletal mesh component inherits the properties from uScene component, but it has additional capabilities. The uSkeletal mesh component class has its own variable called skeletal mesh. So much like the static mesh component has its own static mesh variable, the skeletal mesh component has its own skeletal mesh variable. And a skeletal mesh has a skeleton, and because it has a skeleton, it can be animated. So let's take a look at our bird skeletal mesh from our asset pack and see how the skeleton looks in the Unreal Engine editor. So we'll go back to our content folder, and we have our animal variety pack, inside of which we have the crow folder, and in the crow folder we have meshes, and here's an asset called skCrow. Now you'll see SK, which is short for skeletal mesh, sometimes you'll see SKM, and in the pop-up we see lots of information about this asset. Now we can double click this, and now we're looking at this bird skeletal mesh in the skeletal mesh editor. So this is similar to the static mesh editor, except it has some additional things here. It has asset details, showing us the material it's using, as well as other information, including a skeleton. Now just beside the asset details tab, we have a skeleton tree. And this is showing us a hierarchy of bones in our skeleton. Now we can't see the skeleton, at least not by default. But if we go up to the top and click on character, under bones, we have the ability to show the entire hierarchy of bones. If we select that, now we can see the bones in the skeleton. Now, bones in a skeleton are art being for I'm going to do animate skeleton. There's no will private section a class uSkeletal mesh component. And now we can use this type here. So let's add a variable. We'll go all the way down to our private sect class, U skeletal mesh component.
¿Pero qué es, mae? Yo. Cápsula. Create the fossil object. Yes. You capsule component. Text. Capsule. No entiendo.
Now we can use this type here. So let's add a variable. We'll go all the way down to our
No entiendo, mae. Bueno, sí.
private will say, and we'll go ahead and do that.
Se supone. Class. You capsule component. Aquí pone you capsule component. Ah, era por eso, ya vi. Capsule component. Esperamos. Capsule component equal to default sub object. You capsule. So this one. A ver qué es eso. No. Text. Capsule components. components. Ahí. Mm. Create house of object. You absolutely. I'm gonna use this one. Text. Text. Hmm. Está indefinida. En la línea 14. Ah, en la línea 12. ¿Qué pasa, ma? Qué raro, ma. Yo cápsula. ¿Cuál uso? El primero. Escribimos. Ay. Cápsula 1. Aquí yo cápsula component. Segundo. Cápsula. Cápsula 2. Esto es mal escrito. You cápsula component. Ay, man. No le creo, man. No. Cápsula 1. Cápsula 2. Ahora. Create house of object. Create You capsule component. Esta no me dejó ver, solo uno salía. Espérese. You capsule component. Ahí está, solo uno. Pero me estaba equivocando, madre. Capsule. Ahí tenemos capsule. Two-way define subroutine. You capsule component. Text. Capsule. Qué raro que pasa, man, no sé qué pasa. Ah, es que, ok. Eso lo entendí. Ok, ahí está. Ok, aquí está. Ahora, si le doy aquí, class view skeletal mesh component, aquí vas a ponerle cápsula. No, ¿cómo se llama? No me acuerdo. De cápsula, variables, este aquí. No, qué raro. Cápsula, ¿cómo era? No sé. Aquí está. Esto lo podría hacer una variable, simplemente cambiarla desde fuera. Y aquí tenemos cápsula, set cápsula radius f. Ahora esto lo puedo cerrar y puedo lanzarlo de nuevo. Sí. A ver qué puedo poner. Your skeletal mesh component. Skeletal mesh está. Ah, bueno, esto es como root component capsule. Tenemos skeletal mesh identify subobject view skeletal mesh component. Esto hay que añadirle eso, ajá. Este. Esto hay que añadirlo aquí. Aquí tenemos text mesh skeletal mesh. Y ahora lo cerramos aquí. En teoría no debería. Ay, curva. No debería fallar. Pero bueno, si falla lo reinicio nada más. Aquí me falla, entonces tengo que cerrar esto. Porque aquí me sale este error. Ay. Ok, aquí falta uno de estos y este. Voy a ir a mirar. El volumen está muy alto y yo no me percato de eso. O sea, que me voy a hacer un cafecito. Un cafecito. Un cafecito. Parece que man, el volumen está un poco alto y pues yo no sabía. Entonces, me la voy a bajar el volumen a eso. Listo. Y ahora podemos ver qué cosas podemos modificarle a esto. Syntax, variables, animation, anim class, enable animation. Ok. Bueno, en teoría ya que ya está. Están los dos.
Now, we're going to need to forward declare this type, and we'll do that up here at the top with our other forward declarations. So we'll say class uSkeletal mesh component. And now we can use this type here. So let's add a variable. We'll go all the way down to our private section, and we'll declare and actually create the default sub-object. So we'll go back to bird.cpp, and here we'll create our skeletal mesh component. Now, because we're actually going to create one, we need the header file for this type. So this brings us back to our documentation. I'm going to search the documentation for uSkeletal mesh component. And here's uSkeletal mesh component. Now, if you like, go ahead and scrub through and look at the variables and functions that belong to this class. What I'm interested in for now is the include. So I'm going to copy that include, go back into Visual Studio and paste it just under our include for capsule component. Now we can create this default sub-object. So let's do it. Down at the bottom of our constructor, we'll say bird mesh equals, and we'll use create default sub-object. And I'm going to hit down on my keyboard to highlight the function that Visual Studio's IntelliSense is showing me. That way, if I hit enter, it'll auto-complete that for me. Now, the template type that we should provide is going to be uSkeletal mesh component, and wrapped in the text macro, we'll give it the internal name Unreal Engine will use for this, and we'll use bird mesh. Now we've added a skeletal mesh component. We know that this class derives from scene component, so it supports attachment, and we should attach this to our root component. That way, if the root component moves, our bird mesh will move along with it. So we need to set up the attachment.
No sabía que había que hacer eso. Attach to component. No, poner skeletal mesh. Attach to component. Cápsula. Y luego dice const. No sé qué poner ahí. Fname. Creo que no hace falta ponerle nada más, solamente así. Sí, sí hace falta poner algo más. ¡Ey! Este hijo de puta.
For our bird mesh. And to do that, we use a function that exists on scene components. This is the function we can use to attach.
Ok. Pero si ya. Uy, ¡ay! ¡Ay! ¿Se lo tuvo? coffee for me. Cafecito. Pues, sit. Eso. Bueno. Kabut. There you go. Kabut. Eso, bien. Todo. Ahora, para añadir este mesh, lo que hay que hacer es con este operador. ¿Qué es lo que hace este operador, va? No, voy a preguntarle a Charlie. para hacer a miembros como funciones o variables de una clase. Para acceder a miembros de una clase. En este caso, Skeletal Mesh está apuntando a Skeletal Mesh, que es la clase, y sus miembros son estos. Entonces aquí puedo ver qué hay. Yo aquí puedo ver qué hay. Y si no, al impulse. Y si no, también, si es el nombre, pues lo puedo usar. Estos son variables y estos son funciones. Set o attach to component. Aquí dice el nombre, sería cápsula. Y nada más así. Nope.
This skeletal mesh component to our root component. So setup attachment requires an input parameter of type uSceneComponent. Now, we know that root component is protected, so we can access it from child classes, such as bird.cpp, so we can use root component, or we could use capsule, as we know the capsule is the root component, or we could use the public getter function getRootComponent. All of these do the same thing. Now we know there's a second input parameter. This is of type fname, and it allows us to specify a socket name. Now we haven't learned about sockets yet. We will very soon. But scene components can have sockets, and if we specified the name of a socket, setup attachment would then set up our bird mesh to be attached to that socket. But we haven't set up any sockets, and we see that the default value for this input is nameNone, which is a variable of type fname used to specify that we're not attaching to any given socket. So we can leave that input parameter out of it and just pass in the one required input, which is the component to attach to. So now our bird mesh is set up to be attached to the root component, which is our capsule. So let's click Save All and hop back in the editor, and I'm going to close out of the skeleton editor and the skeletal mesh editor, as well as this animation asset. And here I'm going to hot reload. Now that hot reloading is finished, I can close live coding and hop back into BP Bird. Let's click Save All and hop back in the editor, and I'm going to close out of the skeleton editor and the skeletal mesh editor, as well as this animation asset. And here I'm going to hot reload. Now that hot reloading is finished, I can close live and to be attached that component. Now we know that root component is protected, so we can access it from child classes, such as bird.cpp, so we can use root component, or we could use capsule, as we know the
setup curva. No. Entonces, fuck, ¿qué dice? Mesh. Ahora si pongo solo attach to component. setup attach. Capsule. Questo.
Capsule is the root plane, but scene components can have sockets, and if we specified the name of a socket, setup attachment would then set up our bird mesh to be attached to that socket. But we haven't set up any sockets, and we see that the default value for this input is name none, which is a variable of type fname used to specify that we're not attaching to any given socket. So we can leave that input parameter out of it and just pass in the one required input, which is the component to attach to. So now our bird mesh is set up to be attached to the root component, which is our capsule. So let's click Save All and hop back in the editor, and I'm going to close out of the skeleton editor and the skeletal mesh editor, as well as this animation asset. And here I'm going to hot reload. Now that hot reloading is finished, I can close live coding and hop back into BP Bird. And just under the capsule component, we see that we have bird mesh. Now we can select bird mesh and see its properties in the details panel. And the most important is our skeletal mesh variable. By default, it's set to none, of course, but we can change that. And if we click the drop-down, we see all the skeletal meshes in our project, including skcrow. I'm going to select skcrow, and now we see our mesh here. Isn't that awesome? Details panel. And the most important is our skeletal mesh variable. By default, it's set to none, of course, but we can change that. And if we click the drop-down, we see all the skeletal meshes in our project, including skcrow. I'm going to select skcrow, and now we see our mesh here. Isn't that awesome? So our BP bird now actually looks like a bird. Now, it's facing the Y direction by default, and the actor itself has its X direction pointed to the right, and we consider the X direction to be the forward direction, so we want our bird facing forward. So I'm going to click on this icon to enter rotation mode, and I have snapping enabled for rotation, so I'm going to go ahead and rotate forward. So I'm going to click on this icon to enter rotation mode, and I have snapping enabled for rotation, so I'm going to go ahead and rotate to the right by 90 degrees, just to make sure my bird is facing forward. Now it's also raised up a little too high, so the capsule is not really in the right spot for it. So I'm going to go ahead and hit W to get my translation gizmo and move down. Now I do have snapping enabled for translation, but I can disable that to get more fine-tuned control here. And now our bird has its collision. Now the wings are outside of the collision volume. That's okay. We could either make the capsule a little bit fatter by increasing the capsule radius, but I'm okay with the capsule being like this, as the wings are going to be fluttering and objects tend to pass through feathers anyway, so I'm fine with this. So now our pawn has a mesh. I'm going to compile and save, and back here in the level editor, we can drag in an instance of this blueprint. Let's go to Blueprints, Pawns. Here's our BP bird, and I can drag it out into the level just like that. And I'm going to move it out in front of our player start so that when I hit play, I could see the bird there. Now, by default, we're not going to control the bird and move it around. We have to set all that up. We know that this bird is a pawn, which means we can move it. It can take input once we set that up, and that's going to be what we do next in the following videos. But for now, we're making progress. Our bird actually has a bird mesh. Now, before we wrap up, I'm going to show you something really cool. Back in BP Bird, we can select our bird mesh. And the details panel has an animation section. The static mesh component class doesn't have this. That's because static meshes can't be animated, but skeletal meshes can. Now we have here animation mode with a drop-down. It's by default set to use animation blueprint. And we'll learn about animation blueprints soon enough, but we don't have an animation blueprint for this skeletal mesh. But instead, we can click the drop-down and select Use Animation Asset. And when we do that, we now have a new variable exposed called anim to play. And notice the green line here. You might recall that those animation assets we looked at earlier had the green line, as these types are color-coded. If we go back to Animal Variety Pack Crow Animations, look at that green line on these assets. That's because this shade of green represents the animation sequence type. So that's the type for these animation assets. They're animation sequences. So in BP Bird, we can choose an animation sequence for our anim to play. And if we click the drop down, I'm going to search for fly, and I'm going to choose anim crow fly. And look at that. Our animation is playing, our bird is flapping its wings. So we can compile and save that, and back in the editor, if we go ahead and hit play, we see that our bird is actually flapping its wings. As the wings are get out into the level, just like can. Now we have here called I'm going to search for this bird and fly it around and get a sort of bird's eye view of the levels that we've created. Welcome back. So now that we have a bird pawn and it's actually flapping its wings, well, we now want to actually move the pawn, and that means we need to control the pawn. So let's discuss how that works in Unreal Engine. Now, in the engine, as soon as you start playing the game, a controller is spawned and assigned to you as a player. This controller is sort of your representation in the game. The game sees the controller and considers that to be you. Now, a controller allows us to select a pawn to possess. So we have a BP bird in the world, and this is a pawn. And if we'd like to control this bird, we need the controller that's assigned to us to possess the bird. Now, pawns have the capability of being possessed. Actors do not. So that's why we made our bird based on the pawn class. Now, as soon as we possess the bird, we can then control the bird and configure our project to be able to take input from the user whose controller is assigned to them. And with that input data, we can then manipulate the pawn. So as soon as we press play, we know that we have a controller. So how do we actually possess the bird? Well, all pawns have a variable called AutoPossessPlayer, and we can set its value. By default, it's unset, but if we set it to player 0 refers to the first controller in the world. Now, it's 0 because we start counting at 0. If there were more than one controller in the world, say in a multiplayer split-screen game, for example, then the first controller would be player 0 and the second would be player 1. But in our case, there's only one controller, and that's going to be player 0. So by setting our pawn's AutoPossessPlayer variable to player 0, this means that the first and only controller in our game will possess the bird by default, and then we can control the bird and make it fly. So let's see how this works in the engine. So here's our bird pawn, and by default, if we press play, we're not possessing the bird. In fact, we still have the default pawn, which has the capability of flying around like this, and we just see our bird flapping its wings right there. So we're not actually possessing the pawn, and again, that's because we need to set that AutoPossessPlayer variable on that pawn. And if we did that, then we would no longer spawn this default pawn. And by the way, we can see the default pawn by holding Shift F1 to get our mouse cursor and clicking this icon, which says detaches the player controller, allowing regular editor controls. So we know we have a player controller, and it's possessing this default pawn that can fly around. And if we click this icon, we suddenly can drag around in the world, and if we turn around, we'll see that default pawn. We can actually see a sphere, which is the default mesh assigned to that default pawn. Now, this doesn't exist in the world until we start playing the game, at which point it's spawned by default. And Unreal Engine does this because it doesn't see any other pawns that we've configured to be possessed. Now, we can change that by taking our bird pawn and setting auto possess player. So with the bird pawn selected, we can search the details panel for auto possess player, and here it is, and here's its value. Now by default it's set to disabled, but if we click the drop down we can assign it to player 0 through player 7. Now when we talk about multiple controllers existing in a game, we're not talking about true multiplayer where two players are playing across a network. We're talking about however many controllers exist on our machine, and that's only going to be player 0 in our case. So if we select player 0, then as soon as we press play, then now we can't move around, and that's because we're now possessing our bird pawn. And if we hit Shift F1 and detach, then we can see our bird pawn, and we were attached to that bird pawn. So we don't see that gray sphere because we no longer spawn that default pawn, as the engine understands that we're already possessing a pawn. Now we can click this controller icon that says attaches to the player controller, allowing normal gameplay controls. F8 is the shortcut for that. If we click that, we're now possessing the pawn again. And now we can't move around as we haven't configured any movement functionality for our pawn. So it's a little bit less exciting when we possess our pawn like this, but we're going to change that by configuring some inputs. Now before we do that, I do want to show you that auto possess player is a variable that we can set from C++ rather than doing it from blueprints like this. So let's hop back into Visual Studio, and here's our bird constructor. And if we want to set auto possess player here, we can do that. So let's go ahead and type auto possess player, and if we hover over it, we see its type. Now it's an enum of type E auto receive input, and the type might look a little confusing because it's wrapped in a T enum as byte wrapper. We call these wrappers, and you can see that it has those angle brackets indicating templates. So this wrapper stores an E auto receive input type, and we can set this. So if we set it, we can choose an E auto receive input enum constant value. So if we type E auto receive input and hit the double colons there, we see all the possible enum constant values that this enum has, and we can select player 0. So that's the type of auto possess player. It holds an enum of this E auto receive input type. And if we right click, we can peek the definition of that to see that it's defined here in engine types, and it's in a namespace E auto receive input. That's why we needed to use the scope resolution operator. You might recall back to an enum of this E auto receive input type. And if we right click, we can peek the definition of that to see that it's defined here in engine types, and it's in a namespace E auto receive input. That's why we needed to use the scope resolution operator. You might recall back to regular C++ when first learning and you use cout, and you might have put std : cout because cout was in the standard namespace. Well, this is the same thing here. We have the E auto receive input namespace, and here's that internal enum contained within it that has these different enum constants, including player 0. So this is how we set auto possess player from C++. Okay, so now that we understand that, let's talk about how we can configure input for our project and use that input to actually move our bird. So let's hop back into the editor here. And here in the editor, in order to configure inputs, we have to go up to Edit and select Project Settings. And here in Project Settings, we can scroll down, and in the Engine section, we have Input. So go ahead and click on that, and under Bindings, we have Mappings. We have Action Mappings, and we have Axis Mappings. Now, these two are similar, but their functionality is slightly different. We'll talk about Axis Mappings in this video, and we'll get to Action Mappings in the future. So we have Axis Mappings. And if we click the plus icon, we suddenly have a drop-down next to Axis Mappings that we can expand. And we see an item here called new axis mapping underscore 0, and we can rename this. I'm going to go ahead and name this to move forward. And now we've created an axis mapping.
No, this isn't working now. I need a different way because how to input mapping context in CPP. Input mapping context in CPP.
Now notice that it has a drop down, it has a scale, we'll talk about that very soon, and the drop down we expand key that, well, this page forward to have and our newly created function called move forward. Now once this relationship is established, then our move forward function is going to start being called every single frame of the game. And inside the body of this move forward function, we can access that input parameter value, and its value is going to be different depending on whether or not we're pressing the W key. Now, if we're pressing the W key, then every single frame move forward is going to receive a value through its value input. And that value is going to have a particular numerical value, and by default that value is going to be 1 when the W key is pressed. Now, if we're not pressing the W key, then the numerical value of our input parameter is going to be 0. And we can use this information to do something with that value in the move forward function. So we can check to see if it's 0, and if it is, we can do nothing, and if it's not 0, then we can move the bird forward. Now we saw that there was a scale assigned to move forward, and its value was 1, but if we change that value, then our input parameter, called value in move forward, will be scaled by that scale value. So if we change scale to 2, for example, then every single frame, if we're pressing the W key, then the input parameter's value will be 2 instead of 1. So this allows us to customize the input. Now, if you're not pressing the W key, it's still going to just be 0. So we can still use that information. But this is useful because we may wish to assign scale a value of -1, in which case we could use that value, and when our key is pressed, then because we'll have -1, we could use that to, say, move the bird backwards. And of course, we would still get a 0 if the W key is not pressed. So that's how we use this type of information in that move forward function. Now, the function that we use to bind to our axis mapping is typically known as a callback function. So we call move forward our axis mapping's callback. So where do we do all this binding? Well, we noticed when we created our first pawn class that it had this function, setUpPlayerInput component. This is where we do all of our axis mapping bindings by assigning a callback function to a given axis mapping that we've created in our project settings. So let's do this for our move forward axis mapping. So before we hop back into Visual Studio, we're just going to look right here at our axis mappings and remind ourselves that this is the name of our axis mapping. It's called move forward. We have the W key assigned to it, and its scale has a value of 1. So back here in bird.cpp, we can scroll down to setUpPlayerInput component, and here is where we're going to do our binding. But we can't do any binding unless we have a callback function. So let's make one, and we're going to declare that here in bird.h. Now, I typically make these protected, but you could easily make them private. You could even make it public, but we don't plan on calling this outside the class. So we're going to make this a protected function. And that way, if we ever need to call it in a child class, we can. So let's make this function. Now, it has to be a void function, and we're going to call it move forward to match our axis mapping name. And it has to take a float, and we usually call this value, but you could name that input parameter anything. Now, I'm going to define this function. So I'm going to hover over, click the drop down, and select create definition of move forward. And now I'll get it here in bird.cpp. So this is going to be my callback function. So I need to bind this to the move forward axis mapping. So let's do that. So down here in setup player input component, we're going to bind our callback to the axis mapping. And we do this using this player input component. So setup player input component will be called very early in the game, and it takes an input of type uInput component called player input component. Now we can access this pointer and call functions on it, and the uInput component class has functions for binding callbacks to axis mappings. So let's access player input component, and we'll use the arrow operator to call the function bind axis. Now bind axis requires the name of the axis mapping, and this is an F name. Now, an F name input parameter can take a string literal. So if we wanted, we can just pass in the string move forward. Now, we could also wrap this in a text macro if we want to follow good practices and wrap it in text like we should. And alternatively, another option is to simply pass in an F name and use the fname constructor, initializing it with move forward. So these are all ways that will work with bind axis. Now if we hit the comma, we'll see that there are multiple overloads of bind axis. And the one we see here, 2 of 2, requires 2 more input parameters. One of them is a user class pointer. Now user class exists high up in the hierarchy, and our bird pawn is a distant descendant of that class, which means we can pass in our bird pawn. So if we use the this pointer, this is a pointer to the object of the class that we're in. So if an object of the bird class exists in the world, when setup player input component gets called, by passing this into the function, we're essentially passing in a pointer to this bird object. Now, the user object is the object who has the function that we're going to bind to the move forward axis mapping. That's going to be our bird's move forward function, which we have right here. Now, that's going to be the third input parameter. We have to specify the function. So we need to pass that function in as an input. Now, how do we pass a function into another function? Well, here's how. We're used to pointers being variables that store addresses, right? And typically they store addresses of some object that exists in memory. Well, functions themselves have addresses as well. So we could have addresses of functions. Now in C++, if you recall, this symbol, the ampersand, is the address of operator. So if we use this, then whatever comes after that, we're going to get its address. And we want the address of our callback function, move forward. So to pass the address of move forward into this function, we use the address of operator followed by the name of the function. But the name of the function has to be fully qualified with the class name. So we can't just pass in the address of move forward. We have to pass in the address of this whole thing here, a bird : move forward. So I'm going to copy that. And down here in bind axis, I'm going to pass in a bird move forward. So this is how we can pass the address of a function in as an input parameter to another function. So this line here is how we bind our move forward function to the move forward axis mapping. Now, as soon as we do this, that means that when the game is playing, then our move forward function will now be executed every single frame. It's kind of like the tick function, only instead of delta time, we get value, and value depends on whether or not we're pressing the button or key that's assigned to this axis mapping. And remember, we assign the key W. So we can test this out by printing an on-screen debug message or a UE log. So I'd like to use a UE log. So we're going to type UE log, and we're going to make this a log temp with warning as the verbosity, and we'll use the text macro, and we'll say value, and I'm going to use the format specifier %f, and if I do have %f here, I need to provide a float value. We're going to use our input parameter value. So now we should see a message printed to the UE log every single frame, showing us what this value is. So let's hit save all, and back in the editor, we're going to hot reload. So let's go ahead and do that. And after live coding, let's go ahead and open up our output log. And I'm going to click Dock in Layout so we can see it and keep it open here. Now with our output log open, we're going to click play. And right away, we see this log message spamming the output log. Now we can click in the viewport to gain control of our pawn. And if we press the W key, check this out. We see the value 1. So this is actually
Okay. Join. Button screen debut message. Zero. Color here text forward choices.
showing in here. Do that, provide a float value. We're going to use our input parameter value.
Okay. Perfect. And key value Eso no es. Wiedziałem. Pero no voy a bajar así. Sí. Esto puedo meter en un comentario. Y aquí siempre ponemos reloj. Y aquí ponemos warning. Y aquí ponemos value F. Value